This algebra group presentation. We are the group formed by Gabriel González Pinto, me, Javier González Chavarri, and Joe Casey. Please, Joe, next slide. So the problem we've chosen, so we actually made up, but it's about a farmer who has 10 hectares of land and he decides to use them to cultivate both cereals or vegetables. So because of the limitation of water, he cannot use more than 5 hectares for vegetables, which actually cost like 300 per hectare, and the cereal costs are 100 per hectare. So the benefit he gets from each hectare are 2,000 and 8,000 for cereal and vegetables respectively. So we have to calculate the distribution of the cultivation, and well, that maximizes the benefit. And what is this maximum? So Joe, next slide please. So first we will be working about these two variables, are the hectares of cereal and the hectares of vegetables that will depend on the other constraints we said before. Will be what we will be working with in order to decide what's the maximum. Okay. Go ahead.
Benefit maximizing equation is 200x, 2000x plus 8000y, and that's because the cost of the 1 hectare of cereal is $2,000, and $8,000 is the cost of 1 hectare for vegetables. And so, next slide please, Bobby. And so, our 5 constraints are listed here. Y, which is the amount of hectares of vegetables, must be less than or equal to 5, because you can, as stated in the problem, you can only use 5 hectares for vegetables. The sum of the cost of the two goods must be less than or equal to $1,600, and the cost of the cereal is $100 per hectare. The cost of vegetables is $300 per hectare, and those added together, multiplied by the amount of hectares of each variable, must be less than 1,600. We only have 10 hectares available for use on his plot of land, so the addition of those two must be less than or equal to 10, and per usual, both variables must be positive. Next slide, please. So we will solve this benefit maximizing equation with these 4 steps. First, we will set the constraints in our graph in space equal to each other. We will then show the matching area on all the constraints in a graph. We will find the extreme points and set them equal to each other to find those values. And then once we have the values, we will have all 4 or 5 values, and we will of the 5 extreme points, we will solve them and choose the one with the highest maximizing value to be the maximizing point.
Now we are going to roll all the constraints. Please, John. Next. The first one says that y has to be equal or lower than 5. So we have drawn here the red line, which means that the solution has to be under this value of y. And then we have the second constraint, which is this equation, 100x plus 300y equal to 1,600. And we have drawn also that line, which is this line here, the green line. We have give some values to x and y to represent it. Then we have this blue line, which is this equation, x plus y equal to 10, and we have also given some values to draw the line. So now we know that the solution has to be here in this area, and we have to calculate all these cut points to solve the problem. So to calculate, well, point A, we already know it. We know it is x0 and y5. Now we have to calculate point B, which is going to be the cut between these two lines, the green one and the red one. When we solve the equation, we get these values, x1 and y5. So we have the point B. And now we have to calculate point C, which is the cut between this blue line and the green line, we make the same thing. We solve the equation and we get these two values. So we have this point. Then we have point E, which is 0, 0. We don't have to calculate, we can already see it. And a point D, which we can see also. Next, please. So the question now is, with which point do we obtain the higher benefit? So we can clearly see that with the point B, we obtain the higher profit, which is 42,000 euros. This solution is not valid because you cannot have 0 hectares of cereal and 0 hectares of vegetables. So we know that this one is the solution. So to conclude, we can say that to maximize the benefit, the farmer should use 1 hectare of cereal and 5 hectares of vegetables. This way, his benefit will be $42,000.